Morning, Mass. How are you? Today we have to take a new idea. How do we calculate the coordinates of the image of a point by translation vector? And how can you write the equation of a line that is the translation of another line by a vector translation? Remark. We will start by remark. We know that the image of a point by vector translation is a point. The image of a point is a point, such that we have two equal vectors. It is a remark from the last chapter that the image of a point is a point under vector translation, such that we have two equal vectors. The second remark, the image of a line by vector translation is a line, which is what? Which is parallel to the given line. So these 2 points, I will repeat them. The image of a point by vector translation is a point, such that we have two equal vectors. The image of a line by vector translation is a line parallel to the given line. Activity number 1, given the 3 points, A, B, and C. The first part, calculate the components, the coordinates of the vector. The second part, trace F, the image or the translation of point C by vector translation AB. And the last part, calculate the coordinates of point F. We will start by the solution. To calculate the coordinates of the vector AB, the components, we follow the rule x of AB, x of B minus x of A. We got 3, and y of AB the same. Then look. So the coordinates of vector AB 3, 2. I will remind you something. Graphically, the vector AB, the coordinates of vector AB 3, 2 means that the point A moves horizontally to the right 3 units, and then vertically upward 2 units to have the vector AB. Remark, always to calculate the coordinates of the vector, start by its extremity. Look, the extremity of the vector AB is B. So we start by x of B minus x of A, y of B minus y of A. Now, second part, the figure. Point A minus 3, 2. Point B 0, 3. Point C 2 minus 3. And point F. How can I draw point F? The vector AB 3. Look, I will show you something. 3 units horizontally to the right, 2 units vertically upward. Point C should also move the same as point A. 3 units to the right horizontally and 2 units upward vertically to have the point F. Hide the first part or the first look. Or we can draw vector CF, which is equal to the vector AB. Vector CF, which is equal to the vector AB. And all of us know that equal vectors means that they are parallel, and have the same direction, they have the same sense, and they have the same magnitude. So we have point F when we draw equal vector CF to AB. Now, okay, remark, we have two equal vectors, CF and AB. The remark I started that when we make translation of a point by a given vector, we have two equal vectors. And moreover, I will tell you something. Two equal vectors means that we have what? A parallelogram. We know it. Okay, the last part, how do we calculate coordinates of point F? The last part asked me how to calculate coordinates of point F. We know from the previous explanation that when we have two equal vectors, they have equal coordinates. Equal vectors have equal coordinates. Okay, look. CF equal AB by translation, and remember that equal vectors have equal coordinates. So x of CF equal x of AB, that is 3. and y of CF equal y of AB, that is 2. Therefore, x of CF equal 3. X of CF, it is x of f minus x of C. I'm here now, okay? X of f equal 2 plus 3, x of f equal 5. Similarly, y of CF equal 2 because AB, coordinates of AB are 3, 2. Remember, okay? So the point F, the coordinates of point F, 5 minus 1. And if you want, look, okay, graphically, point F, 5 minus 1. Now, activity 2.